Human later. Hello, or is it audible? Hello, hello, hello. Are వినిపిస్తుందా?
Yes, sir.
Last class, what we were discussing, Anna? Friend. So last class we were doing the alkenes, right? Alkenes. In alkenes, we did electrophilic addition reactions, then free radical addition reactions, right? So then ozonolysis reaction we did in the last class, and the reaction with KMNO4. Okay. So try to do these questions right now. Just next one. KMNO4 entrance of H plus. Write these 4 questions. Akshita Mahendra. Right, completed. Hello. Isha, చేసావా నాన్న? మేఘ్నా? మేఘ్నా చేసావా, రాసావా ప్రొడక్ట్స్? ప్రొడక్ట్స్ ఎవరు రాస్తారు? మనకి లాస్ట్ క్లాస్కి వెళ్ళి చూడు. The first one, Anna? Right? Here we will get the OH. In this case, the methyl shift takes place because this is electrophilic addition. So when we are using the peroxide free radical addition reaction, you get the Br over here. Write the products. Come on, write it down. Oh no. Already 6 member ring adi. Right, acetone plus ethanol. Ethanol. In this case, no, break the bond here. Double bond O. Double bond O. In this case, double bond O. Double bond O. OH. That hydrogen is converted into OH in KMnO4 in presence of H plus. Okay. Products right on the. Next one. Reaction with cold alkaline KMnO4. This cold alkaline KMnO4 generally we are called as Bayer's reagent. Which reagent? Bayer's reagent. Thin hydroxylation takes place. Which hydroxylation? Thin hydroxylation. Thin hydroxylation takes place. Thin hydroxylation means same side the OH groups will attach. For example, if I am taking the compound is like this, So KMnO4. So here is two types of KMnO4. So to differentiate this, so KMnO4 brains of H plus, hot KMnO4. So then cold alkaline KMnO4. KMnO4 in presence of base or cold. So here I told you, first do, in case of air, first we need to do the ozonolysis, then the hydrogens we need to replace with the OH groups. It is two hydrogens are there, the two hydrogens we need to replace with OH. So this exactly takes place, already we discussed. Write it down when I am writing. And syn hydroxylation takes place here. Syn hydroxylation means what, no? Same side, the OH groups will attack. Same side, the OH groups will attack. So don't confuse KMnO4 in presence of H plus, or we could say hot HI, here in this case cold HI. Okay, write the products. And friend of KMnO4, one more reaction, that is the osmium tetroxide, or we can use ORR OSO4. Osmium tetroxide also syn hydroxylation takes place. Cold alkaline KMnO4 or OSO4, syn hydroxylation. Syn hydroxylation is reaction with cold alkaline KMnO. Osmium tetroxide. Osmium tetroxide. Osmium tetroxide. Osmium tetroxide. Osmium tetroxide. There is stereochemistry also is there, no? So stereochemistry, always remember. So this is the trick which I am going to give you. So always cis and trans alkenes. We know cis alkene, we know trans alkene, right? Cis alkene. So first cis alkene plus syn addition. Syn addition means what? Same. CS. So first we'll go with like this. Trans anything. CSM. Meso. Cis compound, syn addition, meso. CSM we could say. So cis once again anti-addition. Anti-addition means opposite direction. One is front and one is back. Anti-addition will get racemic mixture. Racemic mixture. So then trans plus syn addition. TSR, right? Racemic mixture. Trans plus, right, anti. anti-addition, meso, meso. Write it down. Write this 4. So then based on that, syn addition, anti-addition we can say. Come on, write it down. So if we know 1, so we can say remaining easily. For example, T S R. If we know the TSR, trans in addition racemic mixture. So trans anti-addition meso. This syn addition meso. This anti-addition. So we'll go with the car. Car. So remember car. CAR. Cis anti-addition racemic mixture. So once we know the car, so remaining everything is easy. We can easily derive. Write it down. Car is important. Come on. Means racemic mixture. So racemic mixture here, not 11, not opposite. Chlorine or addition of chlorine or bromine to alkenes, it's anti-addition. So before this, just we'll discuss this. For example, tisra, right? KMnO4 friends of OH minus, cold alkaline KMnO4. Write the products. Come on, write the products now. This KMnO4 is syn addition. So cis syn addition what? Meso. What exactly meso? Meso means what, Nana? CH3, CH3, H, OH, H, OH. You get the meso compound. Come on, write it down. Meso. So meso is having the plane of symmetry. Because of internal compensation, if one is R and automatically one is S. Because of internal compensation, the compound is optically inactive. Trans syn addition. Trans syn addition.
Instead of this
So racemic mixture like this. Same OSO4 also same. So in addition it takes place. Same stereochemistry we can write it down. The above one is same mesoiris. Just simply copy. Here is the product for this one. Okay. Last one, the racemic mixture we will get. Right, Nana? For example, same reactions. For example, Cl2 or Br2, friends of CCl4, carbon tetrachloride. What exactly happens? In this case, anti-addition. Anti-addition. So means what? One is one side, one more is other side, opposite direction. One is front side, one more is back side. Now write the stereochemistry. Write the products. Cl2 కూడా anti-addition. Chlorine or bromine. Hmm. This Ravi. This anti-addition. Trans anti-addition. CAR. Car. What is car? Hmm. Last one is trans anti-addition TSM. Meso. Okay. Hello. ఇషా అర్థమవుతుందా వంశిని?
Yes, sir.
So the only one thing you need to understand car. Once we know the car, remaining everything is easy. Car KCR, right? Car TSR. Car means TRS kada, TSR. Like car means was cis anti-addition racemic mixture. Once we know the car, so remaining we can derive. Car means, right, for example TAM, right? T, otherwise TSM, TSR, TSR, car TSR, like that. Here is one of the two important named reactions is coming here. So one of the important area, hydroboration and oxymercuration, demercuration and addition of water. So already we discussed addition of water, right? Hello. CH3CH double bond CH2 H2O in trains of H plus. So we know water will get it at which position? Major product, what I am speaking. At second position, so we'll get this product. So electrophilic addition reaction already we discussed. For example, if we want to prepare in the same reaction, if we want to prepare primary alcohol as a major product, because secondary alcohol this is. So if we want to prepare primary alcohol, so we'll use hydroboration, right? Hydroboration. Hydroboration, so write it down, CH3 CH double bond CH2 plus BH3, trains of H2O2 OH minus, otherwise we will do in the second step. In this case, non-classical carbocation is forming, so that I'll explain the mechanism. But first write it down. 3 moles we will take here. CH3, CH2, CH2, taken thrice B. After doing this H2O2 and OH minus, directly we can write it one step also. We'll get primary alcohol. CH3, CH2, CH2, OH. 3 moles of plus H3BO3 is forming. Write it down. So this is here is major here. In this case, this is major. Come on, write it down. Primary alcohol. To prepare primary alcohol, we will use hydroboration. One of the important reaction, 5 star. Done? In this case, no rearrangements. One more important reaction, oxymercuration and demercuration. Undu. Oxymercuration and oxymercuration, demercuration. Oxymercuration, demercuration. So oxymercuration, demercuration means what? For example, CH3, CH double bond CH2, right? Friends of HgOAC taken twice, right? Plus THF, tetrahydrofuran, water, the step 1, right? And 2, NaBH4 plus NaOH. So we will get this compound, CH3, CHOH, CH3. So in this case, like Markovnikov addition only takes place, right? Markovnikov's addition only. The most important point is no rearrangements takes place. No rearrangements. No rearrangements. Write it down. No rearrangements. In this case, so classical carbon, non-classical carbocation, non-classical carbocation, non-classical carbocation. So no rearrangements takes place. Write it down. I'll explain what is the importance of this reaction. Come on, write it down fast. Then means, for example, if we want to put OH group in different positions, we can use that. For example, CH3, CH double bond CH2. So first H plus OC double bond O CH3, like this. The electrophilic addition reaction takes place. The mechanism, H plus is coming and attacking over here. Like here, non-classical carbocation is forming. So means what? CH3, C, H, CH2, Hg. It is the positive charge. O, C double bond O, CH3, where is partial positive charge? Partial positive charge. So non-classical carbocation. Carbocations are two types. So generally in case of HBr reaction, so for example, free carbocation is forming. This is classical carbocation. In this case, non-classical carbocation. So then water is coming and attacking, no? So from then it's going like this. So directly you can write CH, OH here, CH2, Hg, right? O, C double bond O, CH. This mechanism is not needed actually, okay? But try to understand. So then afterwards, NaOH, NaBH4, NaOH, so CH3, CH, OH, CH2, H like this. Okay, just write it down. So the combination we need to know. Okay. So actually, why I am telling all these reactions? Meghna Rasava, faster. Then now, for example, try to understand. For example, this is a compound, right? H2O and brains of H plus and HgOAC taken twice plus TH of H2O. This is one, in this case 2 only, NaBH4 plus NaOH. The third one is BH3 H2O2 OH minus. Come on. So three products. There is three products are forming. Very, very important. Here is try to understand. Right? So here is if we want to add the OH, we can add. If you want to add, we can add. If you want to ring expansion, is possible. So in this case, first case, what exactly happens? Ring expansion takes place. OH group is forming like this. In case of second case, what exactly happens? No ring expansion at the second position. The third case, what exactly happens? Primary alcohol. See, so we did in year and ring expansion. 3 cases we did the products. So very, very important, write it down. So oxymercuration, demercuration case what? No rearrangements and no ring expansion. Completed? Done? So write one more example. Come on, write the products, these 3. Come on, write it down. Done? So first case, Nana. In this case, rearrangements are takes place. The OH will coming over here, right? So in this case, so no rearrangements, the OH will attacking over here. In this case, OH means one position, second position, third position, fourth position. So if you want to add the OH at first position, we can. Second position also, it's possible. Third position also, it's possible. So means 3 variations are there like that. 3 OH groups. So these 3 are very important when, because at different positions they keep on asking one question, this particular area. Come on, write it down. Now once again, let the questions. I'm just mixing all type of questions. Practice is important, Anna. I'm gonna copy it fast. Copy it fast. Copied up. Hmm? 12, 13, 14 కదా. అచ్చా. సరేనా? Hmm? Come on, write it down. There's 20 questions. Just do it right now and send me in WhatsApp, everyone. Okay, na? So remaining things will continue tomorrow. I'm just waiting for your WhatsApp.